Welcome back, mathematicians. In this video, we will do more examples where we are testing an equation for symmetry. So let's start with testing this equation for symmetry with respect to the x-axis. For the x-axis, we will replace y with the opposite of y and simplify. So we will have x squared minus 4 times, in parentheses, negative y quantity squared equals 4. And we'll simplify this, and our goal is to get back to the original equation. So the x squared term doesn't change. Then we'll have minus 4 times the quantity of negative y times negative y is equal to 4. Negative y times negative y is the definition for negative y quantity squared, and so now we'll find the product of negative y and negative y. A negative times a negative is a positive, so therefore we'll have x squared minus 4 times positive y, and y times y is y squared is equal to 4. So now what we'll do is find the product of negative 4 and y squared. So we'll have x squared minus 4y squared is equal to positive 4. So what we notice is that this does simplify back to the original equation. Therefore, the graph of this equation is symmetric with respect to the x-axis. Now let's test for symmetry with respect to the y-axis. For this test, we are going to replace x with negative x, so we'll have the quantity negative x squared minus 4 times y squared is equal to 4. Well, as we saw before, negative x quantity squared is really equal to positive x squared minus 4y squared is equal to 4. So it does in fact simplify back to the original equation. So therefore, the graph of this equation is symmetric with respect to the x-axis. Finally, let's test for symmetry with respect to the origin. In this test, we are going to replace x with negative x, so we'll have negative x quantity squared, and y with negative y, so we'll have negative y quantity squared, and it's still equal to 4. So now we need to simplify this, so negative x quantity squared is equal to positive x squared minus 4 times positive y squared is equal to 4. So again, this does simplify back to the original equation. Therefore, the graph of this equation is symmetric with respect to the origin, and also the y-axis, and also the x-axis. Let's now look at the graph of this equation to see the symmetry. What we can see is that the x-axis is a line of symmetry because it does cut the graph into equal halves, and we can also see that the y-axis is a line of symmetry, which means that the graph is symmetric with respect to the x-axis and also the y-axis. Now what I've done here is highlighted a few points to demonstrate the symmetry with respect to the origin. So what we see is that we have 3, 1.118 on the graph, and we also have negative 3, negative 1.118 on the graph. We also have another example where we have negative 4, 1.732 and positive 4, negative 1.732. So a graph is symmetric with respect to the origin if for every point x, y on the graph, there is a corresponding point which is negative x, negative y. In other words, the signs are opposite. And we can see that even with our second example because we have a positive 4 for one point, but a negative 4 for the other point, corresponding point. And we have a negative 1.732 for one of the points, and a positive 1.732 for the corresponding point. All right, guys, good luck.